Hi, welcome. Now I am going to show you how to solve assignment problem using branch and bound method in Excel. Okay, what I have here is the number of jobs, so 4 jobs and 4 people. Okay, so I want to assign these 4 people to 4 jobs. Okay, one person can be assigned to only one job. Okay, and similarly one job can have only one person. Okay, and the cost of assigning them is given here. Okay, for example, here it is 16 maybe in thousands of dollars, $16,000 for assigning a person 1 to job 1. Okay, probably assigning a person to job 2 is $43,000. Okay, something like that. Our objective here is to minimize the total number of costs involved when we assign these 4 people to each one to any of the jobs. Okay, now in branch and bound method, when you use it in the paper, you can able to branch it out using the notes and leaves and other things. It looks bit clumsy at times when it especially the jobs and person notes are many or in many multiple. Okay, so now what I am going to do is I am going to show you how to formulate the same thing in Excel and do the branching very fast, almost like a lightning speed. Maybe this tutorial may be little bit slow for you to understand the logic and the concept how to formulate it and branch it. Once you understood, you can do it for any number of jobs and person, same format but in very speed. Okay, so now I will show to you what you need to do is that we have this cost matrix here for each job and each person. What I am going to do is I just copy this and put it here. Okay, and paste it. Okay, first thing what we need to do is that we need to just give a minimum. Okay, so we need the minimum of each row. Okay, this is our first step. Okay, minimum of each row. So this one you can get it by just drag and drop. Okay, then the sum of the minimums. Okay, sum of the minimums. This is second step. Okay, the third step is just for each row you give a conditional formatting for minimum coloring. Okay, you go to top and bottom rules, go to bottom 10 items, it's there in home. Okay, I'll show to you home, conditional formatting, top and bottom rules, which is the bottom 10 items. Go here, make it 1. You want for each row you want to know what is the minimum. Okay, and you give your own favorite color. Okay, I give red. Okay, similarly for this home, bottom 1 items also the same. Then the third row. Okay, and this is also 1, and finally the last row, which is bottom items is 1. Okay, just nice. What we have is only the 4 rows and their minimums. Color coding, this is for we need to know what is the minimum, and this is for each row what is the minimum. Okay, this is the sum of the minimums. Okay, now we started with we are done and we are starting with our branching. Okay, probably I will give this one color, minimums and the sum. Okay, now what I am going to do is that this is the actual cost of the matrix. Okay, because we are in the first step, we are going to consider the first row. Okay, each element. Okay, we are going to retain we are saying the job person 1 to job 1 then we are going to okay, probably I will give the heading also, then it will be useful. Okay, just nice. Okay, so we are going to keep the person 1 to job 1. Then what we are going to do, we are going to leave out these 3 and find the minimum in each row. Okay, so what we are going to do is so for first time it's going to be 16, next time is 43, 68 and 44. So for the first branching, what we are going to do is we are going to have about copy and 4 times, correct? We are going to have it 4 times. Okay, 4 times, because we are going to do it for branching the first row element, 4 elements, so it is going to be 4 times. Okay, so we start doing the calculation of lower bounds. Okay, so first step we are going to keep 16, and we are not going to consider the other elements in the first row, correct? So we fix person 1 to job 1. Okay, similarly we are not going to keep this. Okay, we fixed, so we cannot assign the job 1 to person 2, so and job 1 to person 3 and job 1 to 4 also, so just to make it x. Okay, so automatically it is a non-numeric, the minimum function won't consider this cell. Okay, so what you will have is the first person you fix the you are assigning job first person to job 1, so it is cost is 16. The remaining rows, in branch and bound method you need to check the individual minimum. Okay, the second row except this is 12 is the minimum, third row 25, and the fourth row is the 29. So second one, person 2 is assigned to job 3, person 3 is also assigned to job 3, and person 4 is assigned to job 2. Okay, but these two cannot be same people cannot be assigned to the same job. That is okay. For our branch and bound method, what we are going to do is we are getting the lower bound first. Okay, so make it this, and you get the minimum. So the overall minimum you got is the sum of the minimum is 82. So your lower bound is 82 for when you fix it 16. Okay, similarly for now you fix it for the second element of the row 1. Okay, then you are assigning person 1 to job 2, so the other people cannot have that job. Other people cannot have the job job 2, and also person 1 cannot be assigned to other jobs. Okay, that's why we make it XX. Now automatically you got the minimum 99. Okay, so now similarly for you fix it for person 1 to job 3. Now you just he cannot be assigned to other jobs, job 1, job 4, 2 and 4. Only person 1 can be assigned to job 3. Okay, similarly the job 3 cannot assign to job 2s also, so the same column and rows must be eliminated because we assign the person 1 to job 3, so other things are you make it X. Okay, so the minimum amount here is 146. Okay, similarly the lower bound is 146, sum of the minimums when you have the 68. Okay, similarly you are going to do it for person 1 to job 4. If that is the case, job 4 cannot be assigned to other people also. Now you got in the first branching you have you can know what is the lowest. Okay, so lowest amount is 82. Okay, so this is the matrix, this is the assignment job person 1 to job 1 is promising. Okay, so we are going to proceed with only this, not with others. Okay, so the second iteration what we are going to do is we are going to take copy. Okay, so we are going to paste it here. Now you have to find out person 2. Okay, person 1 is we already assigned to job 1. Person 2 have 3 possibilities, job 2, job 3 and job 4. So it is going to be 3 times it is going to come. Okay, we need to do it for 3 times at least. Okay, so you need to place it 3 times. Now consider the person 2. Now keep 56. Say it cannot be assign the person 2 to job 2, so he cannot be assigned to job 3 and job 4. Same time other people cannot have the job 2. Interesting. So you have 128 as the cost. Similarly for take out 56, you assign that person 2 to job 3. So job 4 cannot be assigned to job 2. Same time those people cannot have job 3, other people cannot have job 3 because it is assigned to job person 2. And just making X only, it is very simple. Okay, so you have 92. Okay, just fine. Now you go and assign the person 2. The second iteration in the branches we are considering person 2. Person 1 we already finished, bringing the person 1's lower bound. Now we are doing for person 2. Okay, so this person 2 is assigned to job 4. Similarly job 4 cannot be assigned to the other 2 people, person 3 and 4. Okay, now you see this is lower bound 128, 92 and 115. Now this is the promising matrix because it gives the lower bound as 92. Okay, so copy this. Okay, probably you just color it some dark color. Okay, so now I'm going to do it for this matrix. This the promising matrix needs to be branched out. Okay, so I finish it for person 1 and person 2. Now for the person 3. Okay, so person 3 has 2 choices, so we need to paste it twice. Okay, so now fix 51. Person 3 is assigned to job 2. So what I am going to do, the same person 3 cannot be assigned to job 4. Same time job 2 cannot be assigned to person 4 also. So what you need to do is the cell which you fix, that row and column you must make it X. That's it. Okay, so then you have 110. Similarly this time make this one X, fix it 35 for person 3, person 3 to job 4. Same time job 4 cannot be assigned to any other people, so it has to have the column also X. Okay, now you can see what is the minimum lower bound. You have 110 and 92. So 92 is more promising, so you need to proceed with person 4 with this matrix. Okay, but you can arrive the answer already, but anyway I will just bring this one. Okay, now person 4 you end up with only one option, so only one matrix, and you have nothing else to do. You just your answer is 92. So this the way you can branch and branch and bound. Okay, you branch it first, find the lower bound. Okay, then out of this lower bound, take this matrix. First you assign to one of the job, the person 1. So similarly 4 options you have, that's why you are doing 4 times. Okay, then you bring the lower bound 1. Okay, then go to the next step 3 times, because the option you have is only 3 times for the person 2, because you assign the job 1 to person 1. Okay, so do it 3 times, then 2 times. By end of second time itself you know the answer, because fourth one you are having only one option. This is the answer. So what we need to do is person 1 has to be assigned to job 1, person 2 is job 3, person 3 is job 4, and person 4 is job 2. Okay, the overall cost you will have is 92. Okay, this is the solution for this problem, and you cannot find lower than this cost. Okay, this the way you can just branch and bound using a small format. Okay, this is very interesting format. Just cut and paste. All you need to do is, this is minimum of this, and you have the sum of this. That's all. Okay, whenever you go for branching, just put a row and column XX. Okay, you select this one 43, you are putting the other row elements X and column elements X. That's it. So now you tell me, isn't it lightning fast? Yeah, yes. Once you know that, you just to put XXX, you'll arrive the answer. Okay, instead of you do it in the paper, one by one branches and leaves. Okay, hope this example is interesting and useful to you, and please subscribe to my channel, so that I will also put another methods of assignment problems and allocation problems. Okay, it will be a very good encouragement for me. Okay, and God bless you. Yeah.